Hi students, welcome to eGanit Gyan. In my last lecture, I have discussed about introduction to polynomials and the zeros of different polynomials like linear, quadratic and cubic polynomials, and their graphs also we have discussed along with exercise 3.1. In this lecture, I am going to discuss about relationship between zeros and the coefficients of a polynomial. Relationship between zeros and coefficients of a polynomial. If you want the introduction of the polynomial topic, go to description box and check out for the link. You will get the video. If you want latest notification from the channel, subscribe the channel and press the bell icon to receive the latest notification. Okay, let us move into our content. Relationship between coefficients and zeros of a polynomial. Suppose you are having a polynomial. Let us take this particular polynomial, 3x square plus 5x minus 2. I have a polynomial in terms of x, which is 3x square plus 5x minus 2. By seeing the power of this, power or degree of this particular polynomial, I can say it can hold two zeros. Okay, it can hold two zeros, and here x square coefficient is 3, x coefficient is 5, and constant term is minus 2. If I find the zeros for this polynomial by splitting the middle term, I will get here 3x square, 3x square I will get here like this, plus 6x minus x. How I will get? Multiply the first and last term, then you will get here minus 6x square, then split. You can split this in two different ways. 1 6 6 1s 6 and 2 3 6. Here if we add or subtract, we will not get the middle term, but here if we subtract, we will get the middle term coefficient. So that I took here plus 6x minus x minus 2 as this will come. From this, if we follow the method, we can get the zeros, 3x minus 1 and x plus 2. There if we make this linear equations 2 equals to 0, then we will get the zeros of that particular polynomial as 1 by 3 and minus 2. Now if we add these two numbers, what we will get here? Minus 5 by 3. We are getting minus 5 by 3. Actually the equation is 3x square, sorry, the polynomial is 3x square plus 5x minus 2, and here if I add the sum, the addition of the two zeros, particular zeros, I am getting minus 5 by 3. Actually this 5 is the coefficient of x, so that is what I wrote here, coefficient of x divided by 3 is the coefficient of x square. Okay, like that. Then here we have the product of zeros. If suppose if I multiply these two numbers, I am getting minus 2 by 3, which is a constant term in the initial polynomial, constant term divided by coefficient of x square, like that. So by using this simple technique, we can frame one equation. Suppose if alpha and beta are the zeros of a quadratic polynomial. I have one quadratic polynomial, ax square plus bx plus c, where a is not equals to 0. What is this alpha? This symbol we should pronounce as alpha. It is a Greek word, Greek symbol. Beta also one Greek symbol. Okay, now we know that definitely we will get two zeros, and that means we can write this ax square plus bx plus c as a product of two polynomials, k into some a minus alpha into normal bracket b minus x minus alpha into x minus beta, x minus alpha into some x minus beta. K is some constant, any number it might be. It might be 1, 2, 3, minus 7, minus 5, any number it might be. I can write a quadratic polynomial as a product of two linear polynomials. These two are linear polynomials where alpha and beta are my zeros. So if I simplify this, k into x into x minus beta minus alpha into x minus beta, if I simplify, I will get k into x square minus x beta minus x alpha minus into minus plus alpha beta. Now I can rewrite it as k into, I can rewrite it as x square. From these two I can take out x common, so I am left with alpha plus beta into x plus alpha beta. Now if I send this k inside, kx square minus k into alpha plus beta into x plus k alpha beta. What is it equals to? Ax square plus bx plus c. If I make equal the coefficients, here this k and a must and should be equal, equating coefficients, equating coefficient. So what I will get? A is equals to k, I got one thing. Then here I can write b is equals to minus k into alpha plus beta, and c is equals to k alpha beta, c is equals to k alpha beta. From this, if I send this minus k on the other side, I will get alpha plus beta is equals to minus b by k is nothing but, b by k is nothing but, we assume we got the value here, I can write here minus b by a, and here also alpha beta is equals to c by k, but the value of k is a, so I can get here a. So here I got the solution, like I assumed initially alpha and beta are two zeros, this is sum of the zeros, this is product of the zeros, minus b by a and c by a. So I can conclude here finally, if I have alpha and beta zeros of a quadratic polynomial ax square plus bx plus c, then alpha plus beta is minus b by a, alpha beta is c by a, like that. So addition of zeros is minus b by a, multiplication of zeros is c by a. Now if we take some examples from exercise 2.2, find the zeros of the polynomial, quadratic polynomial, and verify the relationship between zeros and the coefficients. So first we need to find out the zeros for this particular polynomial. Let us take first question. We have x square minus 2x minus 8. If we split the middle term, what will get? X square minus 4x plus 2x minus 8. If we split the middle term, I will get here by taking from these two terms, by taking x common, I will get x minus 4 as common factor. From these two terms I can take out 2 common, so that x minus 4 will be left. X minus 4 is one factor, another factor is x plus 2. So I can find out zeros like 4 comma minus 2. I got two zeros, 4 comma minus 2. Now I wanted to check the relationship between the zeros and the coefficients. If alpha and beta are zeros, alpha plus beta is equals to minus b by a, I need to get. So what I should do here? For that I need to compare this equation with ax square plus bx plus c. If I compare, I will get here my alpha is equals to 4 and beta is equals to minus 2. Then what is a value? From the equation I can get 1x square, b value minus 2 and c value minus 8. So after finding the relationship between the zeros and coefficients, what is the relationship? Alpha plus beta is minus b by a, I need to get alpha plus beta is minus b by a. If I substitute the values, alpha plus beta, 4 beta is minus 2, which is 4 minus 2, minus this minus I wrote. What is b value? Minus 2, sorry, here I have b value minus 2 divided by, what is a value? 1. So what I will get here finally? I will get 4 minus 2 is equals to 2, which is equals to minus into minus plus 2, and in the same way alpha beta I need to get c by a. Alpha beta 4 into minus 2, 4 into minus 2, which is equals to c by a minus 8 divided by a value 1 from this. 4 into minus 2 is minus 8 equals to minus 8, hence verified. Like that we will find out the relationship between zeros and coefficients. Okay. Now let me take question number 2. I have 4s square minus 4s plus 1. It is polynomial in terms of s. If I split the middle term, I will get 4s square minus 2s. No, I need to split the middle term by multiplying 4s square minus 4s square. So I will get here 4 1s 4, 2 2s 4, yes, sorry, it is plus 1, so that we will get plus 4 here, minus 2 minus 2. So I can consider this one minus 2s plus 1. From the first two terms I can take out 2s common, so I will be left here with 2s minus 1. From these two terms I can take out minus 1 common, so here I will be left with 2s minus 1. Now 2s minus 1 is common, here again I will get 2s minus 1. So zeros, what are the zeros? 1 by 2 comma 1 by 2. I will get 2 zeros, 1 by 2 comma 1 by 2. Now if I compare this one with ax square plus bx plus c, as square plus bs plus c, here I have already alpha is equals to 1 by 2, beta is equals to 1 by 2, then a is equals to 4, from this thing I am copying, b is equals to minus 4, c is equals to 1. If I find out alpha plus beta, I need to get minus b by a. What is alpha plus beta? Actually alpha and beta 1 by 2 comma 1 by 2, 1 by 2 plus 1 by 2 minus b by a. B value minus 4 we are having here, minus of minus 4 by a value 4. 1 by 2 plus 1 by 2 is 1, here also we will get 1. Then alpha beta same way we can find out like this. Alpha beta is equals to c by a, we need to get alpha is 1 by 2, beta is 1 by 2, and c value here, c value is 1 divided by a value 4. So 1 by 4 equals to 1 by 4, and we will say here hence verified, hence verified. Like that we will try to find out the solution. Just have a look and we will proceed. And now we are having question number 2. Here find the quadratic polynomial each with given numbers as the sum and product of its zeros. First number is the sum of the zeros, second number is product of zeros. Okay, they have given two zeros, like sum of the zeros, they have given product of zeros. I will assume here, let the quadratic equation first question, this is for first question. Let the quadratic equation be ax square plus bx plus c, and its zeros I am taking as alpha and beta. So what I can write here, alpha plus beta is minus b by a, I can write alpha plus beta minus b by a is nothing but sum of zeros, sum of zeros, zeros minus b by a, minus b by a. So here what they gave, sum of the zeros is 1 by 4, So from this I can write a value 4 and b value -1. By using the same technique I can write here product of zeros, product of zeros alpha beta, which is c by a. Product of zeros they gave -1, product of zeros they gave -1. So I can take here which is equals to -1. Actually I know a value 4. So what will be the c value? This I need to convert like this. C by a is equals to -4 by 4. -1 I can write like this. Then I can find out c value as -4 and a value as 4. So I got here a value 4, b value -1 and c value -4. Then I can write the quadratic equation very easily. So required quadratic equation, required quadratic equation. What is required quadratic equation? Ax square plus bx plus c. Here what is a value? A value is 4, so I can write here 4a square, and b value is -1 x, and c value is I got -4, which is required. Oh sorry, it is not equation, it is polynomial. Required polynomial in terms of x is ax square 4x square minus x minus 4, which is equals to p of x. Like that we will find out the solution. And for question number 2 they gave sum of zeros. Here we can write directly alpha plus beta they gave as √2 and alpha beta they gave as 1/3. Okay, then what we know? Alpha plus beta actually formula. Let for question 2, let ax square plus bx plus c be required quadratic equation. So what I can write here, and alpha comma beta are zeros. So what I can write here, I can write sum of zeros, sum of zeros is minus b by a. Sum of zeros is nothing but they gave in the question √2. So √2 is equals to minus b by a. Actually this √2 I can write as √2 divided by 1, which is equals to minus b by a. So I can get here a value as 1 and b value as minus √2. Okay, if I compare this numerator and denominator. In the same way, product of zeros, I can take alpha beta is 1/3. Product of zeros I know, oh sorry, it is in bracket. Product of zeros is actually c by a, c by a. So already I got a value here as 1, but here if I compare this 1/3 and c by a, here I will get another value, right? I will get another value. So what I should do here, I should change this one a little bit. I will change this one like this. This numerator I will write as 1/3 divided by 1 c by a. So we can get a value as 1 and c value 1/3. Now we can write the equation very easily, ax square plus bx plus c. So required quadratic polynomial, required quadratic polynomial is ax square is nothing but 1x square plus bx minus √2x plus c. Plus c is nothing but plus 1/3 x, 1/3. C is a constant term. That's it. Like that we will find out the solution. they give the question like that. Now we have another question, sum of zeros is 0 and product of zeros is 5. We can use direct formula also to find out this particular questions. And thank you very much.